Hello, ladies and gentlemen, and welcome back once again. We're going to continue looking at the Grade 7 2002 Gauss paper. We're in the midst of Part C right now. We're up to question number 22. It's a question with an interesting little diagram beside it. So question 22, if you're just reading it for the first time with me, let's read it together. The figure shown can be folded along the lines to form a rectangular prism. Such a figure is usually called a net. Okay, so if we were actually to cut this out of a piece of paper and fold along the lines, we'd be able to fold it all up and form ourselves a rectangular prism. Okay, the surface area of the rectangular prism in centimeters squared is, okay, we're given some of the dimensions in this picture. And this is sort of a little bit of a spatial reasoning question. What we need to do is take this net and see if we can mentally fold it together and determine the surface area just from the net. Now, as it turns out, if you haven't seen nets before, I really encourage you to play with them. You can make nets for lots of different figures. Here in this question we have one for a rectangular prism, but you can make a net for just about any solid if you really have the patience. Turns out that if we were to cut this out of a piece of paper and fold it all up, we would find that exactly the area that is the net becomes the surface area, because each of these little planks here, each of these little rectangles, so here's a 5 by 6 rectangle here, and down here would be a 10 by 5 rectangle. Each of these will become a face of the rectangular prism. So 1, 2, 3, 4, 5, 6 faces. And the surface area is exactly the sum of the areas of the faces, some of the areas of the surface of the rectangular prism. So to solve this question, we really need to figure out the total area of this net. So that means figuring out the area of each of these little rectangles. And therein lies the task. We need to, we've got some dimensions here, but, what are the dimensions of this rectangle? Can I find them? Can I find the area over here? So I'm talking about this rectangle here on the right. So let's redraw our net. We'll go to our paper here, and we're going to redraw our net. Okay. So something like this. Alright, we were told that this was 10, this one's 5, and this one's 6. Okay? So if we were to sort of imagine this, maybe we got A, B, C, D, D, E, and F. If we were to try and imagine how this all comes together, we would sort of have A down here on the bottom. And we would be sort of folding up each of the extra pieces. So each of the pieces folds up. And then on top, and over here is E, so F would sort of swing around. You would come down to the top, and you'd glue over here to the top of B. So that's the idea here. So this one's C, this one's D. In here we have A, and here's B. Okay. So we have a sort of an idea with a net. If you bring paper and scissors to the contest, you could actually, cut one of these out from your scrap paper. I don't recommend always bringing scissors. I feel like you might hurt yourself just in that, I guess it's the same odds as getting a paper cut, maybe even a little less. I don't think you need scissors. You should be able to sort of spatially reason. But, there's no, I don't think there's any rule that says you can't, so if you want to, by all means, bring them. and you can make your own net and see how this all fits together. But knowing how this fits together and how this forms our rectangular prism, we can tell that certain lengths have to match up. So this length of 5 here with B, he's sort of we'll make him green. This green length right here, he's got to match up with this red length on D. Okay. They have to match. Otherwise, we would get some weird lopsided figure, and it all wouldn't glue together right. So that tells us that this length on D is going to be 5. And in the same sort of way, we can tell, this is going to have to be 5 because it's a rectangular face. And then this one's going to have to be 5. And these are rectangular, D and C are rectangular faces, so these are going to be 5. And they have to match up with this length of E, so that's going to be 5, and that's going to be 5. And in doing this, we can start to figure out side lengths and dimensions for each of these rectangles. And if we have the lengths for these rectangles, we can figure out their areas. And from the areas of each of them, we can figure out the surface area, and that's what we were originally asked to do. Okay? So similarly, that's a 6, that's a 6, that's a 6, and that's a 6. Okay? And we have some 10s in here. Okay? Now, this orange length here on C, if we draw him on our diagram, he's got to match up with this sort of lavenderish side length of F. And since they have to match up, we know they have to be the same length, so we get some more 10s. Okay? So, drawing ourselves a little picture of the net coming together really tells us that we can compare these lengths, and in fact, many of them are equal. So, we're asked for surface area. Well, that's just going to be the area of A plus the area of B plus the area of C plus the area of D plus the area of E plus the area of F. And now that I have all their dimensions as rectangles, I can figure out their individual areas, add them all up, get the surface area. So the area of A, well, that's a 6 by 10 rectangle, so that's going to be 6 times 10. How about B? Well, that's 5 times 6. C is 5 times 10. D is another 5 times 10 rectangle. How about E? E is over here in the middle. He's a 5 by 6. And we also have F, that's a 6 by 10. Okay. Now, I should point out that if you know the dimensions of a rectangular prism, so if you know the length, width, and the height, there is actually a formula for the surface area, which I guess I'll write down in a moment. And so if you knew that, and you read the original diagram and knew that we'd have one of the dimensions being 5, 6, and 10, you could have used that formula to get the surface area. I like this method. Sure, it takes a little longer, but I'm not actually writing a contest right now. But it really illustrates how we understand that nets come together to form the rectangular prism. And that's a nice way to understand the problem. Okay. So I'll finish up, and then I'll give a little formula in terms of length, width, and height for a rectangular prism, and give you the general surface area. Okay? So that is a shorter method if you do know that formula, but if you were stuck, this is an excellent way to reason things out. Okay? So 60 plus 30 plus 50 plus 50 plus 30 plus 60, so 60 and 50, that's 110. 60 and 50, that's another 110, so that's 220. Then we have 2 30s, so that's 60. So 220 plus 60, that's 280. Don't worry, you could just get your calculator out and do that. So we should have a surface area of 280 centimeters squared. Let's see if that's one of the answers, because if not, we may have screwed up somewhere. Okay, 312, 300, here's 280. And the other possibilities were 84 and 600, but I'm confident with our 280. So C is going to be our answer. Okay. So there it is. There's C. All right. Now, in general, and this is just if you're curious as to how we could do this with a formula, if we have a rectangular prism and we have length, width, and height, so in general, the surface area of a rectangular prism is 2 times, and then we do each of the pairs. So length times width plus width times height plus length times height. Okay? And we can see that reflected in the actual numbers we got. If we just looked at our net, we would have had, say, a height of 5, a length of 6, and a width of 10. So we take each of the pairs, 5 times 6, 5 times 10, and 6 times 10, and we see that each of them appears exactly twice in our sum for surface area. Okay? So that's a general formula for surface area. Of course, the volume is length times width times height. And these are really the only things that you're ever asked about a rectangular prism. So if you didn't know that formula, you do now. Okay? Either way, we're finished the question. We've got our answer of C here. And that was question number 22. We're going to move on to question number 23 in the next video. And I'll see you guys then for more of the grade 7 Gauss.